Hey everyone, welcome to today's Explainer. We're doing something really cool today. We're taking a virtual factory tour right into the heart of China to completely demystify how electronics are mass produced. It's kind of like peeking behind the curtain of the modern world, so let's get into it. All right, I want to kick things off with just a completely staggering number, 10,000. That is the exact amount of LED driver pieces that a single factory worker completes in just one day. I mean, think about that. It's an absolutely mind-bending volume of production for one human being. So here's our roadmap for this explainer. We're going to check out China's lighting hub, take a look at the human assembly engine, walk through the process from PCB to final product, witness some pretty extreme quality control tests, and wrap up with how they package it all for the world. Let's hit the road. Starting right off with part one, inside China's lighting hub, Henglan. It really is the absolute heart of mass production. This entire manufacturing ecosystem we're looking at is built right around this town, which sits just about 20 minutes away from the massive wholesale center of Guzhen. Now, what's wild here is the stark contrast between what we think a factory looks like and the high-tech reality of Henglan. Honestly, most of us picture, dusty, chaotic environments, super loud machinery, maybe some broken-down infrastructure. But the reality? It's literally the opposite. These factories are housed in buildings that look more like five-star hotels. We're talking pristine roads, completely free of stray animals or hazards, and, get this, highly secure automated NFC card elevators just to get onto the production floors. And you see, this local infrastructure, it's designed purely, 100% for efficiency. They actually provide integrated residential areas right there on site for the workers, complete with top-tier air conditioning and totally weatherproofed loading bays. Add to that these impeccably clean streets that safely support transport speeds up to 100 kilometers per hour, and it just becomes the perfect centralized hub. The goal is simple. Ensure that from worker comfort to rainproof cargo loading, absolutely nothing slows down the assembly engine, not even a little bit. Which brings us to part two, the human assembly engine, and the discipline behind all this speed. Let's actually meet the people powering this massive scale of manufacturing. This part right here brilliantly illustrates the extreme dedication of the workforce. So the factory relies really heavily on husband and wife working teams. And the rules, they are absolute. 0 cell phones allowed on the assembly line. No unauthorized breaks, no wandering around. It is a completely silent, highly focused environment. No casual talking whatsoever. They don't even permit tobacco or chewing products. The discipline is so intense that the boss doesn't even need to be on the floor to supervise them. I mean, honestly, they're probably more focused than most of us are in a quiet library. And because these couples are often working side by side on the line, a single husband and wife team can churn out 20,000 finished pieces in a single day. 20,000! They just completely power through their daily quota and then take turns going home and cooking after these really intense shifts. But that brings up a really crucial question, right? With such breakneck speed, how on earth do they ensure that these electronics actually work reliably? I mean, how do you prevent just mass-producing garbage when you're moving that fast? Well, let's look at part three, from PCB to product, to see the step-by-step manufacturing logic. To really understand how they guarantee quality, we kind of need to slow things down a bit and trace the exact chronological journey of a single driver board from a raw PCB all the way to a finished product. When you break down the chaos, the process is actually incredibly structured. Step one is mounting about 20 to 22 individual components, things like transformers, right onto the board. Step two is manual soldering to fuse all those parts together. Step three, they use a fast-moving blade to trim the excess wire pins right off the bottom. And finally, step four involves adding these really precise insulation caps to prevent electric shocks. It's just a rapid, highly fluid motion from start to finish. Now let's zoom in on that second step for a second. Manual soldering in this factory literally means dipping the underside of the populated board directly into liquid solder, completely by hand. While the tiny microcomponents might use automated robots, it is just fascinating that the heavy-duty soldering is still done rapidly and flawlessly by a human being. It really proves that highly skilled human labor is still driving the key manufacturing stages. Right after it's soldered, it goes directly to the trimmer. A dedicated worker runs the soldered board over a lower blade, which instantly shears off all the protruding pins, leaving this perfectly flat, clean base. And, this tiny, simple step of shearing the pins, it is absolutely crucial. It ensures the board fits perfectly into its final casing without puncturing the casing or creating some kind of electrical hazard in the final product. All right, part 4, extreme quality control tests. Or, as I like to call it, welcome to the torture chamber. Because now that the product is built, it steps right off the assembly line and into the main laboratory. See, quality isn't just checked once here. It undergoes 3 distinct phases of really rigorous testing to catch any potential failure before shipping. Phase 1 is an initial automated test right after the components are mounted. Phase 2 is a post-glue functional test done completely by hand just to make sure the unit actually powers on. And finally, Phase 3, well, that involves extreme stress and environmental testing inside the main laboratory. I absolutely love this specific detail from the main lab because it connects this abstract Chinese factory directly to the harsh realities of the global market. Neha, the quality control lead, explains that to prepare for the intense, brutal summers of Rajasthan, India, they actually push their heat cabinets up to 99.9 degrees Celsius, and then they leave the product running inside for almost an entire week. Baking an electronic component at almost 100 degrees Celsius for an entire week, that is the ultimate proof of durability. If it can survive that specialized oven, it can pretty much survive a scorching summer absolutely anywhere on Earth. And they go way beyond just intense heat. They aggressively simulate power grid failures too. They use a surge test machine to blast the product with up to 10 kilovolts. That simulates severe power cuts and massive electrical shorts. At the exact same time, they use an LCR meter to precision test the transformer's frequency and measure the exact thickness of the carbon sides. So they are hunting for both massive electrical weaknesses and tiny, microscopic manufacturing flaws. So the big takeaway here is their zero-tolerance policy. If a product fails any of these extreme tests, it's done. It is directly rejected and scrapped. There's no remaking or salvaging bad units. They achieve this incredible quality not just by building things well, but by ruthlessly destroying anything that is subpar. Which brings us to our final stop, Part 5, Packaging for the World, boxing up 10,000 daily victories. Let's see how this immense daily output actually makes its way out the door. Even the packaging here is engineered to completely prevent human error. Basically, 14 raw boards are packed into a single module. Then, those products are stacked vertically into boxes. And this physical vertical stack is genius because it means an incorrect number of pieces simply won't fit into the box. It prevents miscounts entirely. As they pack, the worker is simultaneously counting and doing the final visual check, while everything gets meticulously logged with dates and testing parameters. So at the end of it all, exactly 150 perfectly tested, manually soldered, and extreme weatherproofed pieces go into every single final dispatch carton. No more, no less. It's just a perfectly streamlined conclusion to a wildly rigorous manufacturing journey. As we wrap up this explainer, I want to leave you with this thought. If global supply chains can run this flawlessly through immense discipline and really strict testing, what lessons can we apply to our own local industries? Could embracing this level of systematic efficiency be the key to unlocking manufacturing potential in our own backyards? Thanks for exploring this amazing assembly engine with me today. Keep asking those big questions, and I'll catch you on the next explainer.